Here's a number that can single-handedly make or break your training run: the learning rate. Set it too high and your loss bounces around or explodes. Set it too low and training crawls or gets stuck while short a good solution. For years, people agonized over picking the one perfect value. But here's the trick the best practitioners quietly use. They don't pick a single value at all. They change it as training goes, and that one idea, learning rate scheduling, is arguably the most impactful tuning decision you can make. Let's see how it works. Think of the learning rate as a curve over the whole training run, not a single fixed number. Follow how a good schedule shapes that curve, stage by stage. Most modern training starts not at the peak, but near zero, and ramps up over the first few hundred steps. This warm-up calms the early, chaotic phase where the model still knows nothing and one big step could send it flying. It matters most for transformers and for large batches. Once warmed up, the rate reaches its peak and holds high for a while. This is the exploration phase. Big steps cover ground fast, letting the optimizer race across the lost landscape and find a promising region before it settles down anywhere in particular. Then the schedule steadily lowers the rate as training proceeds. Step decay drops it in stages. Exponential decay shrinks it smoothly, and the now dominant cosine schedule eases it down along a curve. Whatever the shape, the steps grow gentler and gentler over time. Finally, the rate arrives at a tiny value near the end. Here the model stops covering ground and instead fine settles into a good minimum, making delicate adjustments without overshooting. Big early to explore, small late to converge. And that arc is the whole point of schedule. So why bother changing the rate at all? Here's a fixed value against a schedule, side by side. A single constant rate forces an impossible compromise. Pick a big one and you move fast early, but then bounce around the minimum forever, never quite settling. Pick a small one and you settle nicely, but waste ages crawling there, and you might stall in a bad spot along the way. One value simply cannot be right for the entire run. A schedule sidesteps that trap by using the right rate at the right time. Large early, so you explore quickly and cover the landscape. Then small late, so you settle gently into a strong minimum without overshooting. Each phase gets exactly what it needs, and that is why a good schedule almost always beats any single fixed choice. Strip it back, and 3 ideas capture learning rate scheduling. The core idea is simply to change the step size as training proceeds, rather than freezing one value for the entire run. The best rate early in training is not the best rate late, so you deliberately let it evolve over time. The shape follows a clear logic: large early to explore, small late to converge. High rates race across the lost surface and find good regions fast. Then low rates make the careful final adjustments that lock in the accuracy you actually keep. The finishing touches stabilize and sharpen the result. A warm-up ramp at the start tames the chaotic early phase, and a decay toward the end, especially the cosine shape, settles the model cleanly into a sharp minimum. Together, they lift both stability and final accuracy. All right, let's lock in what matters. Learning rate scheduling means changing the step size during training rather than holding it fixed, and it's one of the most impactful tuning decisions you can make. A large rate early lets the model move fast and explore, while small rate late lets it settle gently into a good minimum without overshooting it. Common shapes include step decay, exponential decay, and the now dominant cosine schedule, and most modern training adds a warm-up that ramps the rate up from near zero. Because it's usually defined relative to total training length, your main choices are the peak rate, the warm-up, and the decay shape. If you like seeing the knobs behind modern AI explained without the fluff, come explore more with us at Standarity.com. We'll see you there.